Good morning, everyone. Okay, so let's start. Lots of you are here. Well, where's my pen? Okay, so yesterday we have learned how to subtract vectors and what is the way to multiply a vector with a scalar, right? Yes, good morning, everyone. Those who have just joined. So there were two cases, right? So let's just very quickly get this, right? Suppose I'd give you something like let's say c vector equal to -5 into a vector. Okay, so what can we say about directions? What can we say about directions of c vector and a vector? Come on. What can we say about direction of c vector and a vector? Yes, very good, Tamanna. That's right. Well done, Divya, Krisha. That's right. Direction of c vector is negative is not correct. No. The correct answer is that these two vectors, c vector and a vector, are opposites, right? The direction of c vector and a vector are opposite to each other, right? Okay, I hope that is absolutely clear. So that is, if a vector is in this direction, then c vector will be opposite to that. Okay, right? No, that's wrong, Rahul. C towards left, A towards right. No, not like that. Sorry, wrong. It could be anywhere, but whatever it is that A and C are opposite to each other in direction, right? So that is what is the meaning of this minus sign again, right? This means C is opposite to A. That's what it means, wherever A is, right? Okay, fine. Now let's go to another way of addition or another law of addition. Okay, right now we are going to talk about another law of addition. and that law is parallelogram law of addition of vectors. Okay, that law is parallelogram law of addition of vectors. So earlier we have seen triangle law of addition, triangle law of subtraction. Now it's time for another law, parallelogram law of addition. Now what this law is it's just that it's one, this law is one more way, this law is one more way to add vectors. Okay, we have already studied triangle law. This is one more way to add vectors. Okay, so now let's see what this law is, right, and what are the steps. So step 1, draw. Let's say we want to, okay, if we want to add, write it as follows. If we want to draw a vector plus b vector, okay, suppose we want to draw this. So for step 1 is draw both vectors from same point, that is with common tail, right? So step 1, draw both vectors with common tail. Okay, so let's see what it would look like. Let's let's say that this is vector A, and let's say that this is vector B. All right. Okay, so we have drawn both of those from the same point or from the common tail, right? They have a common tail. Now step 2, complete a parallelogram, using the two vectors as adjacent sides. So what this means is we take these two sides, these two as adjacent sides. Adjacent means next to each other, right? Okay, so we take these two as adjacent sides of a parallelogram. We have to draw a parallelogram now using these, right? So let me complete the parallelogram. Do you understand? I've completed a parallelogram. Of course, if you draw it with a ruler, it would be easier, right? I am not being able to draw it very nicely, frankly, because my drawing is not so good. Yeah, so like this. Clear? We completed the parallelogram. Okay, step 2 clear, everyone? Is step 2 clear? Have a look at what I've drawn. I took these two, A vector and B vector, and made a parallelogram out of it, right? Okay. Now step 3. Step 3. Draw a diagonal vector from the common tail of A vector and B vector to the opposite corner, right, or vertex, if you understand geometry related language, then vertex. So what have we got here? We draw a diagonal vector from the common tail. So we take the common tail of A and B. From there, we draw a vector to the opposite corner. So from the common tail to the opposite corner. Okay, right? Okay. And finally, step 4, we just name it and we are done. Step 4. This diagonal vector, or this vector, okay, this vector that you have just drawn is r vector, which is equal to, okay, so this is the addition vector. That's how you add. So in four steps, you have added a vector plus b vector. So this is r vector. Again, r vector stands for a vector plus b vector. Okay, that's how you do it. Clear? Are all the steps clear, everyone? Again, I would request you to remember these steps, because you may have to use this law. Okay, now of course, I am sure you will have a question, what's the need, right? You will have a question, what's the need for this second law? We could add with triangle law also, right? No, Gracie, I've drawn dotted line because there is nothing over there. Okay, so that was just to complete the parallelogram. Okay, so it is that, why do we need one more law to add, right? We already have one triangle law to add. Why don't we just do it like that? Well, actually both laws are same. Let me tell you that both the laws are same and they give the same result. Let's see why whatever we have done here is correct. Okay, and how is it related with triangle law? Let's have a look. I'm going to change the page. Oh, okay, fine, there we go. So let's see how this is same actually as triangle law, right? So to understand that, you need to understand one sentence. Generally, vectors can be shifted, that is moved. Okay, shifted, that is moved. Okay, but not rotated. Please be careful. Generally, vectors can be shifted or moved without changing their meaning. Okay, so what do I mean? What's this sentence telling you? It's telling you that, suppose, listen to this carefully. Suppose this is a vector, and I've drawn one b vector over there. Let's say like this. So then what I can do is, I can take this b vector and shift it. Shift, that is move, not rotate. I can shift it like this, and I can put it here if I want, or I can put it here if I want, or I can put it here. I can put it wherever I want, right? I can shift it, I can move it there, but its meaning will not change, right? The vector itself will not change. So here it is b vector, there also it will be b vector, because every vector is determined or has only two things. One is magnitude and the other is direction. So as long as you don't rotate it, see, if I will only shift it, you see the direction of arrow remains same. Do you agree, everyone? I hope all of you can see what I'm doing. As long as you only shift it, the direction of the arrow remains same. Yes? Okay. right? This is one of those things that is very easy to explain on a computer, right? It would be nightmare to explain on a board, right? But here I can do it so easily thanks to OneNote, right? So you can see you can shift it, direction does not change. Obviously magnitude will not change. Why magnitude? Because magnitude is indicated by length. તમે એક પેન લઈને પેનને આમ સાઈડમાં મૂકી દો તો લેન્થ બદલાઈ જાય? Of course not, right? So magnitude is this length. So that obviously will not change, right? So that's why as long as you shift a vector, as long as you move or shift but not rotate, okay, there is no change in the meaning, right? It's all okay, no problem. Generally આવું હોય, right? There are some cases where doing this is not allowed. પણ એ ક્યારે આવશે ખબર છે? એ હજી આગળ આવશે. I think what maybe like a few three, I think after 4 or 5 chapters we'll have to worry about it. Okay, right now we don't have to worry about this. So such vectors are called free vectors. What is meaning of a free vector? You can move it anywhere, it's free to go, right? You can move it anywhere, it is free to go, it will not change anything, right? But see, if you rotate it, things get different. Have a look. If I'm going to, I wish I can rotate it here. Oh. If I'm going to rotate it, I believe all of you understand that the angle will change. For example, have a look. See, I rotated it, right? I hope all of you could see that. I rotated it, the angle changed. Agreed? Right? So when you rotate it, the angle will change. Right? So if angle will change, that means the direction is changing. So it means the meaning will change, right? So finally, we can just understand this sentence. Shifting vectors is allowed. Okay, no problem. No, nothing changes. But rotating some vector, rotating a vector is not allowed because it will change the vector, right? Because it will change the vector. So please remember this. Shifting a vector is allowed, rotating a vector is not allowed. Okay, looks like only Saurabh is understanding all this. Others, is all this clear, or are you having questions? Falak, only you are having this problem, I believe. Others, I think, are having it okay. Right. Now, what does this have to do with addition by parallelogram or addition by triangle? Let's have a look. So suppose I would draw a vector A here, and then someone gives me a vector B here, like this. To add them directly like this, which law should I use? Have a look at this. To add them directly, right? We want to add. Which law should we use? To add them directly, which law should we use in this situation? Okay, in this situation, as I have described, which law should we use? Yes, very good. We should use triangle law of addition. Follow the steps of triangle law. What does it say? From the head of first, we draw the second, correct? So that is triangle law of addition, not parallelogram law, everyone. Right? Okay, fine. Let's do something interesting. I will draw the same vector B here, right? So basically what I'm actually doing is I'm supposed to copy it, right? Again, copy paste is possible on a computer like this. Oh, sorry. Instead of copying, it got shifted. Just give me a minute. Okay. So now I have it here. See, it's just like I moved it, right? Correct? It's just like I moved it. So now I want all of you to just look at the yellow B. Okay, just look at the yellow one, right? Don't look at the green one, just look at yellow one. Ignore this for a while. Okay, now if we want to add, we should use which law? If we want to add, we should use which law? Yes, parallelogram law, because their tails are together. So if we add it, it's going to be something like this, right? If we add this, it's going to be something like this, right? And then we make a diagonal. And then we, oh, sorry. Yeah, then we make a diagonal like this. Do you see, do you all see that if actually B vector would have been here, still this pink one would have always been R vector equal to A vector plus B vector, either way, even by triangle law and even by parallelogram law. Agreed? Yes or no? I hope you understand what I'm saying. Even by triangle law or parallelogram law, it would have been the same. So what's the key thing to understand? What's the key thing to understand? Both these laws are correct, of course, and they always give the same answer, right? They always give the same answer, right? I hope you understood that. Yes, agreed, Rohan. It's just like that. So why to have two laws? Simple. When you are given vectors head to tail like this, then you use triangle law. It's easy to do it. But when you are given vectors with common tail like this, then you use parallelogram law. I hope that makes total sense to you, right? Both are always correct and they give the same answer, right? So it is up to you what you want to do. Jene je fave karo, right? Okay. Personally, I like this. My preference, my general preference is triangle law. That does not mean I don't know this. Okay. I also know the parallelogram law, but like I said, this is my preference. Okay. You can have your own preference, no problem. Right. Let's go to the next thing now. Okay. Next. Now we are going to talk about something very interesting, right? And that is components. Okay. First of all, components in plain English means parts. Components in plain English means parts, right? Okay, પણ આપણે એને parts નહીં કહીએ, આપણે તો components જ કહીશું. Why? We love to use difficult language, right? Okay. So let's see what we have here. So first of all, I'll take you through what components are in a very interesting way. Let's say that this is one vector A. Okay. Let's say that this is one vector A. And here suppose is another vector B. Right? Here suppose is another vector B. Right? So then if you draw the R vector by following, let's say, triangle law, then you get R vector equal to A vector plus B vector. Now what this means is this R vector is actually made up of two vectors. Do you agree? Do you agree with this sentence? Have a look at this equation. That will help you realize what I'm saying. This R vector is actually made up of two vectors. Which two vectors? This R vector is made up of which two vectors? બહુ ઓછા લોકોને સમજાણું લાગે છે. I'm not really satisfied. Are you all clear about this? Which two vectors? Yes, yes. Now I'm getting some answers. Okay. Right. Fine. Correct. So we can say that these are two parts or two components of what? R vector. Correct? I think all of you do realize that. Right? Okay. But although this is a very nice way to do it, right? But there is an even better way. And that better way is what people use everywhere, right? And it is called rectangular components. Word બહુ અઘરો લાગે એવો છે, but don't worry, I'll make it very easy for you. Rectangular components means those components that are perpendicular to each other. Okay. Generally rectangular no meaning એવો થાય એવો નથી, but when you take perpendicular components it makes a rectangle. Okay, that's why we are calling them rectangular components. Okay, હજી આનાથી અઘરા વર્ડ છે આના માટે, પણ તમારે જાણવાની જરૂર નહીં અત્યારે. I will tell you eventually, but not right now. Okay, so what does this mean? Have a look. Suppose the same R vector, let's say this is that same R vector. I could also imagine or think of two vectors like this. Do you understand what I've drawn? Okay. So let me tell you why it's called a rectangle, or why it is called rectangular. Again, if you draw the other side here, જે ઓલું parallelogram law માં થતું હતું, think about this. જો થઈ ગયું ને rectangle, opposite sides are C and D vectors, right? બની ગયું rectangle. I hope you understand what we have drawn here, right? That's why this is called rectangular. Yes, tada. Okay, so what's the nice thing about this? The nice thing about this is that this is unique. Matlab, if you do it like this, if you write it like this, so that C vector is perpendicular to D vector, then you can get only one value of C vector and only one value of D vector, right? I hope you understand what I'm saying. This is unique. If you do it rectangularly, then in this particular way it's going to be unique, right? બાકી તો તમે આની જેમ કરવા જાઓ ને તો ઘણી બધી પોસિબિલિટીઝ છે. કેવી રીતે? જો આ A સપોઝ થોડોક વધુ મોટો હોય તો સપોઝ A vector is all the way till here, okay, and then B vector would be from from here to here. See, it's a completely different thing, but still this equation is right. So I hope you realize that in general this is not unique, but when you talk about rectangular it becomes unique. I hope you understand what I'm saying. આમાં તમે આગળ ન જઈ શકો. What I mean to say is, suppose you'll think, okay, let's take C so big. No, then this will not be rectangular, કારણ કે perpendicular draw કરો તો અહીંયા આવે જ નહીં. I hope you understand, right? So this is not possible here. It has to be like this only. Okay, but anyways, that's only a minor point. So what's the use of, yes, we are using 90 degree, that's why this has become a rectangle. Okay, right? So what's the use of rectangular components? Let's talk about that. હવે બહુ important point છે. Please be very careful everyone. Let's say that this is as usual, east on this side, west here, north here, south here. Okay, and we are spying. Okay, and right, we are spying. So suppose this is that terrorist house, right? The terrorist starts from here, right? Starts from origin. Let's say the terrorist starts from origin, moves over there, moves over here, moves over here, and finally reaches this point. Okay, finally reaches this point, right? Okay, so now, oh, sorry. So now if you would think about, uh, displacement vector. Okay, think about displacement vector, right? Again, displacement vector is a vector drawn from initial position to final position, right? I hope you remember that, right? From initial to final, photo method. Just use the photo method. So from here to there, correct? That would be the displacement vector. So suppose this point is, let's say, 30 meter, 40 meter. Let's say this point is 30 meter, 40 meter, right? Okay, so I'm sure you have learned trigonometry. So based on that, I am sure you understand that this distance is 30 meter and this distance is 40 meters. Agreed? Is everything in the diagram clear? Is everything in diagram clear? All right. So I'm going to write something here. I can say that the displacement vector is actually 30 meter east along with or and 40 meter north. Do you understand what I've written? I'm waiting for you. Did you understand this? Okay, let's make it even more clear what we are talking about. See, this is a vector. Displacement is a vector. So do you realize that I could here make its two rectangular components, one like this till here, okay, like let's call it C vector. Okay, C and D, I'm just taking some letters. Okay, you can choose your own letter, no problem. Let's say this is D vector. So do you understand that I can also write it in this form. I can also write it in this form where C vector is a vector which is 30 meter in the east direction. People, be careful. Be careful. Yesterday I taught you that this is wrong. This is wrong. Okay, but this is correct. What's the difference? What's the difference between these two? Yes, because I'm specifying that this is a vector. जो है vector no uniform pair हो जाए, right? Vector team. So because it is in the vector team, yes, it should have a direction, right? So that's why this is only magnitude, so it's wrong, but this is correct. Okay, so do you see that C is 30 meter east and then plus D, where D is actually 40 meter north, right? Yes, so D is 40 meter north. So do you understand that this is one component, right? And this is one more component. Again, component means parts, yes, right? Okay, Now, now the thing is, every time we don't, we don't like to specify east, west, north, south. Okay, sometimes it's not even possible to decide that. So what we do is for x-axis and y-axis, we typically we have developed special symbols, right? For x-axis and y-axis, we have developed special symbols, right? Okay, so that's what we are going to talk about now, right? But first, I want all of you to understand that components are again here we are talking about rectangular components. That means we are talking about these two which are perpendicular to each other, as you can see, right? You could also have done it here. I'm sure you recognize that. It would still give you the same. Okay. Yes, Veda. In that case, you should. Okay. So let's talk about those special symbols. Unit vectors. So what are unit vectors? Unit matlab one. Okay. Unit indicates one, right? So what is a unit vector? Very simple definition. Okay, it's a definition. A vector whose magnitude is one or unit. Okay, unit એટલે one, right? A vector whose magnitude is one, right? One as unit or unity, right? That's what we call it in words. So a vector whose magnitude is one is called unit vector. Okay, a vector whose magnitude is one is called unit vector, right? Now think about this. Okay, let's write it in symbol first of all. Just a second. So if vector A has magnitude 1, then vector A is a unit vector, right? Okay, they have a special symbol. They have a special symbol, right? Unit vectors have a special symbol, everyone. So what's that special symbol for unit vector? What's a special symbol for unit vector? It will definitely be a hat or a cap, right? Each the vectors no uniform thing. But along with that, there will also be a separate, a slightly different sign. Okay, that's it. Along with it, there is a slightly different sign, right? Okay, so what's that sign? Well, here, this. On the top of it, on the top of the symbol, you write an arrow, upward arrow like this. Okay, this is the symbol of unit vector. So what does that mean? If I write like this, if I write like this, okay, then that means it is a unit vector. Okay, if you write like this, it's a unit vector. Okay, if you write like that, it becomes a unit vector. So if you write b hat like this, b hat or b cap, how do we read it? B hat or b cap. Okay, whatever you like. Some people, yes, there's one more thing, b caret, right? It આમાંથી જે તમારે બોલવું હોય, no problem, all the three are valid. What this means is magnitude of this vector, magnitude of the b vector is 1. That is what it means. Okay, right? So unit vectors are indicated by this symbol. Please remember that unit vectors are indicated by this special symbol. Say vector. Okay, it is a vector, everyone, right? It is a vector but a special one, right? So you can say it is the captain of that team, right? Okay, but सबसे छोटा captain, right? Now let's talk about the usage here. How do we use this concept, right? Okay, see, think about this very carefully. A vector here, let's say its length is 3 centimeter. Let's say its length is 3 centimeter, right? So suppose I'll take one unit vector, then its length will be 1 unit, that is 1 centimeter. I hope you understood that, right? Then I'll have to draw 3 such unit vectors. Agreed? Do you understand what I'm saying? Right? I hope this is clear to all of you, that a vector equal to 3 into unit vector, right? 3 times, because we'll have to draw it 3 times. Okay, now, so you know, this actually demands for a symbol. How should we write this? Okay, આવું તો ન લખાય 3 into unit vector. So a hat, listen to this carefully and you can write it also. A hat is the unit vector in same direction as a vector. Okay, this is what we mean by this symbol. Whenever someone writes a hat means the unit vector in same direction as a hat, a vector. Similarly, if someone would write b hat, then that would mean unit vector in same direction as b vector, right? So here what we have done is this one single blue arrow is a hat, this another blue arrow is second a hat, this third blue arrow is a hat. So now I can finally write that instead of 3 into unit vector, I can write 3a hat. Okay, instead of 3 into unit vector, I'm putting this value. Let's take one more example. Okay, this time you try it on your own. Suppose you'd have a b vector like this, which is, let's say, 6 centimeter long. Then how should I write b vector? It cannot be negative, Ayush, because negative means opposite direction, right, of a vector. So it cannot be negative. The correct answer, people, the correct answer is 6b hat. The correct answer is 6b hat, right? So do you all realize that when you write a vector like this, whenever you write a vector like this 6 indicates magnitude. Agreed? Yes or no? And this, હવે vector ને હોય જ બે part. Vector is actually having just two things, magnitude and what's remaining. What's remaining? Vector has two things, magnitude and, yes Dharmi? Vector has two things, magnitude and direction. Very good. તો આ બાકી રહ્યું એ direction indicate કરે. Right? Okay. So whenever we are writing it like this, okay, no problem Dharmi. Whenever we are writing it like this, what we are doing is we are writing the magnitude separately and we are writing or indicating its direction separately. Okay, we are writing the magnitude and direction separately, right? In fact, you can do this for all vectors, right? For example, do you understand that I can divide the 6 on the other side? I can write it like this, yes or no? Okay, yeah, right. So finally, in general, okay, so this is something that is always true, right? This is what we get. Do you identify with this? This is written for B. This is magnitude, isn't it? Have a look at this formula. Yes, Jaikit, if you have a question, type it, please. Right? Okay. So please remember this, everyone. Please remember this. I can also say this. I can also say this in words. Okay, no problem, Jaikit. I can also say this in words. To obtain unit vector. To obtain unit vector in direction of a vector, we divide a vector by its magnitude, by its own magnitude, right? Do you understand this sentence? Yes, Ankita, you are right about that. Joy, again, have a look at this. See, if you go back to this equation, it is actually that 6 is the magnitude, isn't it? So symbol of magnitude is this, right? Okay. Then remember, magnitude is a scalar. This is a scalar. Scalar means like a number, correct? You can simply divide this number on the other side. If you divide this number on the other side, what shall you get? You'll get B vector divided by magnitude of B is equal to B hat. So that's what I've written here, right? Again, if you read this sentence, okay, I hope that made it clear. All right then. So please remember this formula and this is its meaning, correct? What I've written here is the meaning of that formula. જો આ 1 upon magnitude એ લખો કે સીધું division માં લખો ચાલે, both are okay, right? Not like you have a problem with either, right? So the key thing to understand is that a vector can be written as a magnitude followed by unit vector. Agreed? because unit vector actually indicates direction. बराबर ने? Unit vector actually indicates direction, right? So that is what we are going to use in components now, right? This is exactly what we are going to use in components. Okay. So again, coming back to the rectangular components example that I was giving you. Okay, we're going to use the same example, right? We're going to use the same example, right? Where we had the displacement vector, let's say like this, and we said that this delta r vector is in two parts, for example 30-meter east and 40-meter north. Okay, and I wrote it as a vector c plus a vector d, right? Okay, so we wrote delta r vector maybe as a vector c plus a vector d, right? And this is a right angle. So now we are going to say, we are going to define, or we are going to say that unit vector in positive x direction, unit vector in positive x direction is called, okay, I know naam che, it has been given this name, right? You cannot ask why. Is called I hat or I caret or I cap. Again, this is I caret, right? So unit vector that is in positive x direction is called I hat, right? And unit vector in positive y direction, unit vector in positive y direction is called j hat. Okay, this is very crucial, you must remember it. Okay, yes Saurabh, you're right. Hat is the symbol for unit vector. Again, everyone, if you recall, okay, when we put something on top of, when you put this kind of symbol on top of a, it means this is a unit vector. So writing I hat is required because it is a unit vector. તમે unit vector કહો અને પછી આવું લખો તો ન ચાલે. This is not even vector, right? Okay, it's in the wrong team. So you must write the symbol of unit vector. What's the symbol of unit vector? This. Okay, so if you use it here, I want all of you to think about this, right? હવે આમાં magnify કરવું પડશે. Okay, here we go, right? So that I can draw it properly. Retha will. Okay, so now we have ultra high resolution satellite image of the terrorist. Okay, so look at C vector, right? Look at C vector. Actually C vector was 30 meter in length. Okay, actually C vector is 30 meter in length. So do you realize that, listen to this carefully, Gracie, I explained what is meaning of I hat and j hat. We are writing hat because they are unit vectors, and I and j are just letters we have chosen. Okay, you have to choose that only because everyone in the world follows that. Okay, so they are like names given. Okay, they are like names given. So if this is 30 meter, do you realize I can draw 30 arrows like this of 1 meter length? Yes or no? 30 arrows. Agreed? Yes or no? Everyone? अरे वाह राज, काम करने को दे दो. So that's why people, listen to this carefully. that means I am drawing 30 times I caret. Why I caret? Because I caret means any unit vector that you are drawing in x direction. This is positive x, correct? Right? X. Everyone, listen to this carefully. I'm saying that each such 1 meter arrow, is actually I hat. Okay, I think it shall be better if I draw a separate diagram, a new one. Okay, let's not try to use it. So what I was saying is that if you would draw one I caret, its length would be 1 centimeter. If you draw one more I caret, its length would be 1 centimeter. If you draw one more I caret like that, to make that C vector, which is 30 centimeter long, 30 meter long, sorry, not centimeter, meter, excuse me, 1 meter, 1 meter, 1 meter, unit, don't forget, unit. Okay, so to do that, you'd have to draw 30 such eyes, right, like this. Okay, so that's why I'm writing this. How many of you understood this? I plus I plus I plus I, like that. How many times? 30 times. Okay. Anyone has a question with this? Anybody? Okay, Sahil has a question. I will answer that. Okay. Okay, if we write C hat, okay, fine, Joy, you and Sahil have same question. I will answer that, right? Okay, so there is a good question here, that can't we write it like this? Okay, yes, we can. This is also correct. Okay, you can write it like this. Okay, but this is better. I'll tell you why it's better. If you look at this, you will not know. You will not know C vector is in which direction. I repeat, you will not know C vector is in which direction, right? You will not be able to know that. But if you write like this, you will know that C vector is definitely, in positive x direction, right? Okay, you won't know this. Okay, so you don't know this, but here you know that this is in positive x direction. Yes, the reason is, the reason is I caret is a special vector, right? I caret means unit vector which is in positive x direction, right? That's what you have to remember, right? That is how everyone deals with it, right? I hope that made it clear. Okay, I hope that made it clear. Joy and Sahil, I really hope you understood why we should write it like this. This is correct, this is okay, no problem, but that's better. That's it. Okay. Now just like that, let's do it for D. Let's do it for D vector and then we'll wind it up. Okay. Just 1 minute. Have a look at D vector. D vector has a length 40 meter, correct? D vector has a length 40 meter. So for making that D vector, like this, I will have to draw like this, correct? 40 times, 40 unit vectors. But this unit vector is j hat. This unit vector is j hat, right? Because once again, j hat means unit vector in positive y direction. Is this clear? Is this clear, everyone? Okay. So finally, if I combine these, and we come to the last point for today, we can write it like this, right? કેમ આવું? આ C છે અને આ D છે. I hope that is clear, right? You can't add, remember 30 chairs plus 40 tables is not 70 anything, right? This is wrong. I hope you understand. You can't add. Just like 30x plus 40y is not 70. Barabar ne? So you can't add them. Remember that. Vedant, still you couldn't add them in a single number, right? So it won't help. Okay, so this is it, right? That's it for today. This is how you finally write vectors. No, why would you want to divide them? Divya, why would you want to divide them? The class is over. I'm only answering questions. So hang on if you want to listen to answer. Okay? Or you want to ask your own questions. Right? Otherwise you could leave. No problem. I will not teach anything else now. Can we divide both of them by 10? Why? I mean, on your own, you cannot divide anything, right? If you divide, meaning will change. You can take 10 common. You can't add this, of course, because they are unlike terms. Sorry, just a minute. You cannot add them because this is 30 I caret and this is 40 J caret. They're different, right? It's just like this, 30 apples plus 40 oranges is not anything 70, right? This is nothing 70. I hope you understand that this is wrong. Fruits no keta. Yes, Rahul, we'll talk about that tomorrow, all right? Okay. Other than I caret and J caret, can we use any other alphabet for our own? No, big warning. Okay, you must use I caret and J caret. I caret for positive X, J caret for positive Y. Fix it, right? Because if you will use something else, it will create a lot of confusion. Of course, physics will not be wrong. Okay, physics or maths will not be wrong, but it will create a lot of confusion for everyone. Vedant, it's because of direction. I explained that a lot yesterday. Vedant, I hope Arkan you understood. You got the answer to your question. All right. Anyone has any more questions? What? Rain has a vector? Saurabh? I don't understand what you're saying, Saurabh. Okay, I think that's enough. All right. Goodbye everyone.